Thank you for turning up. My name's John, and I'll introduce you to the rest of the team. We've got Noir, we've got Dan, we've got Britannia, and we've got Sean. And we are Team FooDash. So, what is FooDash, I hear you say? Well, it's more than a state of mind. It is a cross-platform mobile AR game. So it started out as a healthy eating game, but as the time wore on and the energy levels sapped, it became an eat as much junk food as you can kind of game. So what I'll do is, I'll run through the video in a second, but what I'll do, I'll just run through the MVP. We wanted to create an AR platformer where the player controls an emoji across an AR playing surface. There was also collision events. We wanted them to lose lives, to gain points, and to fall off the edge of the AR playing surface as well. And we also wanted a backend, a secure serverless backend, to make sure we could store the player data and we could store the username and password. So, without further ado, let's have a look at the game. So we have the instruction panel, we have a login screen, we enter username and password, we have a sign up screen here, so we've already signed up. Sean's going to play the game, so she'll sign in. That is not a real email address, by the way, for GDPR purposes. Okay, we've got instructions on how to play FooDash. We've got a leaderboard as well, which we can scroll through. Obviously, Bruce Bogtrotter's coming first at the moment with 300 points. He's doing very well. Now, it gives some instructions here. We point the camera at the surface, then click. We've got the menu at the top there, which shows the score and the lives. The surface appears. The food appears, so we've got the junk food, and we've got some fruit and vegetables, and you tap the emoji around the playing surface. He gets bigger as he eats the junk food, gets smaller as he eats the healthy food. And watch this. Oh, almost gone off the edge, but not quite. And then, oh, he's dead. Game over. You scored 30. That's not bad, that's not bad. Okay. So I'll pass you over to Sean now, who'll talk more about the front end. Thanks very much.
Thank you very much, John. And yeah, not quite beat Bruce's score yet, but I'm getting there. So I'll talk to you a bit about the front-end technologies we used during this. While some back-end aspects were involved, it was a very front-end heavy application, and it was really important for us to make a good decision about what AR technology we were going to use. Part of this, we really wanted to challenge ourselves with kind of using tech stacks we've not been exposed to before, have no real understanding of. From the AR point of view, we looked at Expo first. We didn't decide to go with it because it was quite limited in what it could do with AR. It just wasn't a viable solution for creating a 3D game. And we also had, from the point of go, wanted to make a crossover platform game. The AR aspect only works with iOS, so we take that one off and opted for Viro React instead. So Viro React, this one was cross-platform. It had a good test bed, which meant that we could quickly kind of recompile, reload the screen, and test the app. Because we were quite new to the technology, we had to do a lot of trial and error, so that aspect of quick re-rendering times was really vital at the start of the project and obviously throughout. The last reason why we chose Viro React, it had a physics engine, which was really kind of viable, really crucial to the gameplay, sort of making the emoji move around and the foods kind of fall. We had to use a lot of physics to design that. Dan will speak more about that later on though. After we picked Viro React, for the user interface aspect, we went with React Native. It just seemed like the most sensible solution, as Viro React itself is built upon the React Native framework. They kind of work hand in hand, they go really smoothly together, and obviously we wanted a smooth operation as possible to create a really good app. We were also really familiar with the code base of React Native, and again, it was cross-platform, so that ticked those boxes. The 3D models that you see on the screen, we did leave these in the front end rather than putting them in a back-end database, just to make the user experience a lot better. It would mean faster rendering times rather than having to make a call and then render them, which just meant that the game loading time was a lot better. And on that note, though, I'll pass you to Noir to speak more about the back end.
So when we first started the app, we thought for the back end, we'll create our own server and make API calls to it. But as we looked at what we want our app to do and what our minimal viable product is, we decided that we don't need to create our own server, and instead we can have a serverless backend. So the data that we did need to put in our backend was the user's email, password, the username, and their highest score. So as a team, we decided to use a cloud database, and we decided to use Firebase as it's something we've never used, and we thought, why not take on the challenge of using a new platform. So for our login and sign up, where the user has to put the email and password, we used Firebase authentication. This was really good, so the passwords were already secure, and also it also ensures that people got signed up twice on the same email. And for the leaderboard, we needed the username and the highest score. And because Firebase is non-relational, we did have to do our own, where we had to link Firebase authentication and Cloud Firebase. And we did this using the UID, which Firebase authentication gives. And another problem that we encountered with Cloud Firebase was it caused problems on using it on iOS and Android, which now Britannia will talk about.
Thank you, Nawar. So yeah, I'm going to tell you a little bit about the challenges, or some of the challenges that we faced during the past 2 weeks while we've been creating our app. As Nawar said, we faced a challenge with regards to Firebase. We decided earlier on that we wanted to create a cross-platform app, and we noticed really quickly that that caused an issue when we pulled and merged to GitHub and then pulled it down off of GitHub, because we got this lovely red error, not exactly this one, but we did encounter one of these, saying, well, some of us did, and some of us didn't. We realized that it was because some of us were using iOS and some of us were using Android. So we managed to fix that by creating 2 separate files, one for iOS, one for Android, and we had our app connect to those depending on which operating system we were using. The second challenge that we wanted to mention was the knowledge of tech. Or more the lack of knowledge of the tech we were using. We started playing around with the technologies, and we realized quite quickly what limitations there were. We had really high hopes of what it would be able to do, and then realized, oh, maybe we can't do that. So something that we had to keep doing was talking constantly with each other, communicating, looking at our MVP to see, do we need to update this? So very often we would check in with each other and make sure that that was still viable. The last and probably biggest challenge that we faced was learning to use Viro React. Because we did, like we've been taught, we went on to Viro React's website, we looked at their docs, but their docs weren't necessarily as nice as we would have hoped, or as detailed as we would have hoped. We tried using some of their examples, and again, got this nice red screen, which we quickly dubbed to the red screen of death. Oftentimes, we wouldn't get errors like this, which are very clear about where the error is and what type of error there was. Oftentimes we would get a server error 500, and there would be a big long line of text with lots of trues, falses, characters, numbers, you name it, it was in there, and we were like, what do we do with this? So what did we do to fix that? Well, a lot of trial and error, to be honest. And also debugging. Some of the errors were really good. You could go online, and some people had encountered them before. So they gave us lots of different solutions, and we were able to use those to see if that would fix it, and most times it did. When it didn't, we reverted to pair programming and to swarming, which brings us on to our next slide, which is programming practices, and I'm going to hand you over to John for that.
Thanks, Britannia. Hopefully I've got no more videos to show, so I'll be all right. So, we use GIF version control, plenty of branches to spike ideas, and obviously then before going back into dev again. We had Trello boards set up from the start as well. We tried to use it for the front and back end and kept 2 separate major Trello boards, and then obviously differentiated for individual tasks that we spiked off and we try to test. We come across, because it was a brand new technology, it was AR that we were using, we've never used it before, we obviously had a lot of dead ends as well, so we had to kind of have a lot of meetings. So we had a stand up in the morning, every morning, and we also had one in the afternoon as well, just to make sure that we were keeping on track, because it's easy to get kind of sucked in to like a rabbit hole, and you think, okay, I'm going to do this idea and I'm going to spend all day on it. But we really only had about 8 working days to do the whole thing from start to finish, so we had to be very careful with our time management. So those meetings were crucial, and we made decisions as a team on what we dropped and what we carried on doing as well, so that was really good. Pair programming was at the heart of it as well, obviously. Britannia mentioned that before. And this swarming technique that I've never heard before, but Britannia had looked it up online and was explaining it at the start of the process. And it was really useful, because we'd start off in a pair programming situation, and then we'd hit a real brick wall, you know, because we were using Viro, we were using, you know, sort of a serverless backend. Lots of things were trying to talk to each other. We were trying to then put JavaScript functions in everything, and some things were just not working at all. We had one instance where we were trying to render a 3D object. We were trying to map over that object to make the little guy go bigger and smaller, and we had to work out where to put the function, how to run that, and it was quite a, you know, it was quite a challenge. That was near the end of the project, and we managed as a group to kind of work out what to do and how to overcome that challenge. So all in all, it was really good. So the final section will be Dan talking about the challenges, more challenges we face. So I'll hand you over to Dan now.
So this project was a great learning opportunity, and we've learned a lot throughout these past 2 weeks. So we started out with no experience of making games at all, so giving ourselves the task of making a 3-dimensional augmented reality mobile game was a huge challenge to give ourselves. One big hurdle was at the start of the process in learning that we had to use Viro's physics engine to make objects interact with each other. So that involves applying properties such as like force, gravity, friction, restitution, mass to objects and functions to make the objects like not fall through the ground or bump into each other, things like that. And that was really difficult to pull off, particularly because we weren't using a game development platform such as maybe like Unity. We were just like writing the code straight off the bat. That made it quite difficult to get to terms of what was happening in the game as we were writing the code. So we overcame some of these challenges by utilizing pair programming, learning to communicate effectively as a team, and learning to refer to the documentation for reference. There's also a lot of trial and error involved in order to build up our knowledge of the tech over time. And these were some really important skills that we had to learn, and they helped us as we went through the rest of our project. We also learned a lot about time management. So we had a lot of ideas at the start of the project, but as we went along, we learned the importance of having a really clear minimum viable product, or MVP, in mind, and sticking to that as much as possible. Often this meant putting aside some of our ideas so that we could focus on the core elements of the game instead. We also learned that it was important not to get stuck on one problem for too long. So sometimes it's really helpful to, you know, if you're hitting a brick wall, just move on for a bit, do something else, work on something else, come back to it later with a clearer head, maybe with like a partner to help you out. Also sometimes you just have to rethink an idea. If it wasn't working, maybe there's a reason it's not working. Maybe we're not approaching technology in the correct way. So just having a rethink about what we're trying to accomplish and how we can do that maybe differently if it's not working the first time. Pair programming was really helpful for tackling some of the harder issues, as it allows us to bounce ideas off each other and get different points of views from different people. In conclusion, we're really proud that we've managed to make a 3D augmented reality game with no knowledge of game development at all in the space of 2 weeks. So I think we're all really happy with the end product. And yeah, thank you very much. Any questions?